Yet another video. This is exciting stuff. I'm doing double award science physics. I'm doing the paper one. It's the Northern Ireland Board. See ya. It's Wednesday, the 23rd of November 2022, and it's on in the morning. It is worth 70 marks. Time is 1 hour. So let's have a look. We're going to do a duel with the examiner. We're going to have to show the knowledge that we know. We're going to have to see what he or she has set up for us to fall into. And we have the mark scheme because we're working for every mark. We want as much of that 70 as we can get. Let's have a look. Radioactive emissions. The following question is about the harm that radioactive emissions can cause. In this question, you'll be assessed on your written communication skills. I keep saying this. Capital letter. Full stop. Spellings are correct. It is a sentence. It has to mean something. It can't be gobbledygook. The examiner can't give you marks for gobbledygook. Ionization, we've done this. It's where a neutral atom loses or gains an electron. Remember, you can only lose or gain electrons. What harm can ionization cause to the human body? Damage cells, damage DNA, cause cancer. What is background radiation? It's radiation due to the cosmos, from outer space, from rocks on the earth, from nuclear accidents, from hospitals. Radiation due to other sources, whenever there is no radioactive source present. State one type of human behaviour that adds significantly to background. Nuclear warheads, nuclear accidents, medical. And here in good old Northern Ireland, we live in the Mournes. The granite emits radon gas. Is it deadly? Well, ask a 90-year-old man from Hilltown. Is it deadly? He'll tell you it's not. Right? There are 3 types of radiation, which is stopped by a sheet of paper. You should know the table. Alpha stopped by paper. Beta stopped by aluminium foil. Gamma stopped by several centimetres of lead. Most penetrating. Look, I've even written all the ones I know. You look at the mark scheme. Look. I did that so that you can remember. But then you have to look at the video. Here we go again. A cross zebra. That's the number of protons. That's the number of nucleons. That's the atomic number. That's the atomic mass. This is 19 protons. This is 39 nucleons, of which 19 are protons, so there's 20 neutrons. Now, here comes the first bit of a duel with the examiner. This time, it's in an atom. So there are electrons in the atom, but remember, if he or she asks about a nucleus, there are no electrons in a nucleus. But this is atom. Look at the way I've read the question. I slow down and I read. Remember, P-E-N. There's 19 protons. Therefore, if it's a neutral atom, it doesn't say it's an ion, so it's an atom, 19 electrons and 20 neutrons. What's the overall charge? Nothing. Remember the relative charge. Like there's your proton. It's got a relative charge of +1. The electron has a relative charge of -1. They are the same size relative to each other, but different in charge. Opposite in charge. And then the dear old neutron has 0 charge. Isotope. Explain in terms of particles what an isotope. Same atomic number, different atomic mass. Remember, we did our old friend, carbon-12, bog standard. The fancy one. 6 protons, 6 neutrons, 6 protons, 8 neutrons. Same atomic number, same number of protons, different number of neutrons. See the way I've done my working out here? That's what you do. You take your time. You're in no rush. You're not doing anything else anyway. You do your working out. See the way across zebra. See the way I've done it again. Show you're working out. The examiner mightn't be interested in the mark. It'll slow you down and think. Question number 3. Warning. Warning. It's a distance time graph. It's not a velocity time graph. Distance time graph, you can only tell 2 things. The distance at a certain time. And the slope or the gradient is the speed. That's it. This one's a wee bit slippy. Doesn't start naught. You take your time when you're reading the graph. The examiner will try to dupe you into either writing down the wrong times or the wrong distances. So it says, during which time period is the bike travelling fastest? Greatest slope, look. Slope. Where's the greatest slope? That one. Read off. 25 to 35. Do you see? I tell you to use the old ruler, look. I use the actually, I can read that. Slow down and think. Slow down and think. Describe the motion of the bike during the time 35 to 50. It stopped. There's no change in distance. It stopped. It's stationary. How far has the bike travelled during the time 0 to 30? 0. Oh, look. 0 is 25. It didn't start at 0. Do you see what the examiner did for you there? And then that's 75. You see, where's 30? Look, you see what the examiner did there? He's looking up in there. 100. So it's 100 minus 25. Again, simple question. Good dupe. Good ploy by the examiner. You use the values in the graph to calculate the speed of the bike during the first 25 seconds. Now be careful. You see that by there at the start? So look, distance over time. So the distance is 50 over 25, which is 2. Be careful when reading off the graph. Use a ruler. Slows you down, makes you think. Now here comes another efficiency question. This question is about the efficiency of a bulb. Some of the energy is wasted. Some of the energy is useful. Remember, energy in over energy out by 100 gives you percentage efficiency. Energy in over energy out gives you efficiency. It's just a number from 0 to 1. It has no unit. Joules divided by joules. The light bulb uses 600 joules of electrical energy. 450 joules of energy are wasted. Wasted. 150 joules are useful. So, efficiency is, look, see what I did there? Pillock. Energy in over energy out. I wrote the formula down. I'd lose a mark for that. And rightly so. I wrote it correctly up here. I wrote it correctly here. And I made a pillock of myself. There's that question done. Simple question, and I messed it up. A drawer can be opened to a maximum distance of 60 centimetres, 0.6 metres, 0.72 joules. Force, work done equals force by distance. Should be in the bracket. Going to rearrange the formula, look. Done this time at a number. Again, calculator. Don't start dividing it in your head. No point getting it wrong because laziness. 1.2. This reminds me of the video of Brian Cox in the big NASA chamber where they sucked all the atmosphere out of the chamber and they had the feather and the bowling ball falling and they both hit the ground at the same time. Complete the sentence for an object falling freely. In a vacuum, due to a force called gravity. It's only an attractive force for those who are going to do A level. The object will fall with an acceleration of 10 meters per second squared, and the acceleration is given by the symbol small g. When the object falls through air, a second force acts on. Name this force. Well, it's friction or air resistance. Always remember, friction opposes motion. So if it's falling down, the friction is acting up. And what effect will this have on the size of the acceleration? The acceleration will be smaller. Here we have it. There's the formula. Do you know it? A equals V minus U over T. For definition, change, rate divided by time, change, subtract them. Final velocity minus initial velocity over the time taken is the acceleration. Meters per second squared. Meters per second. Meters per second. Seconds. At position A, the velocity is 12. At position B, it's 36. The time is 3 seconds. Look. Show the calculation. Units there. Straightforward question, that one. Here we come with a pressure question. What did I tell you? Worry about the pressure. What area are you going to ask you? There's a digger with caterpillar tracks. The digger has a weight of 60,000 newtons, so that's 6,000 kilos. That's 6 ton. It exerts a pressure of that. So that's the force. That's grand. That's the pressure. That's grand. But look, pressure equals force, newtons. Pressure, pascals. Over area. We're rearranging this. Again, you stop the video. You have a look. See what I have written down. Check the mark scheme. Am I doing all the right things? You look at the mark. You look at the calculations. I work out the area to be 6. But look. Our friend the examiner has set a trap. It's 1, so 1 has to be half of 6, which is 3. It says caterpillar tracks are used so the digger will not sink in muddy ground. Why does the digger not sink in muddy ground? The pressure is smaller because the area is bigger. But on this one, they're inversely proportional. Big area, small pressure. Small area, big pressure, assuming the force stays the same. Next question. An electric motor is used to lift a load of 0.3 kilos. What sort of energy does it gain? Potential energy, mgh. Have you learned that? It's in the mind map. Joules, kilos, 10 meters per second squared, meters. The load is lifted to a height of 150 centimeters. God damn it, the examiner has set a pitfall. The height has to be in meters. Think. Calculate the increase in potential energy. Mark for that. 4 marks. Again, see my exam technique. I'm not rushing this. I'm thinking it. Write that down and check all the units. A different electric motor has a power output of 750 watts and did 2,250 joules of work in lifting a load. How long did it take to lift the load? There's the formula. Power equals energy over time. Learn it. Power measured in watts, grand. Energy measured in joules, grand. Times measured in seconds. Great. Look. Here comes the hard part, rearranging the formula. I want the time. I do the calculation, look. 3 seconds. See rearranging the formula? Can you do that? There's no formula. Formula to learn. Ask Granny. Do you know all your formula? Have you learned them? I can't learn them for you. Define the moment using words only. Now, I'm not going to spend half an hour writing this out. Words only. Moment. The moment of a force is the force multiplied by the perpendicular distance. Let's have a wee look at the mark scheme for number 8. Moment. Let's have a read of it here. Moment is the force times the distance, or the symbols, if defined. Perpendicular distance. Look. Perpendicular distance from the pivot. Did I get it right? Moment is force by perpendicular distance from the pivot. No name for a pivot. Fulcrum. So did you get that one right? Have you that one in your list of what to learn? Here we go. A uniform rule. The centre of gravity is in the middle. It's 100 centimetres long, so it's going to be at 50. There's the 50. That's 70, so that's 20. What did I keep telling you about? Watch the examiner, they're going to mess the distances up so you write down the wrong distance. That's 70, that must be 30, because it's 100 centimetres long. Let's have a look. The 4 newtons makes it go anti-clockwise. This force here makes it go clockwise. So it says, what is the direction of the moment exerted by the weight acts in the centre? All the weight appears to act in the centre of gravity. Uniform, always in the middle. What do we call the centre of the weight? Centre of gravity. Calculate the value of the moment. Force by perpendicular distance. Force, look, the distance is 30. Newton centimetres. Next question. Last question. Have you worked hard? I know that I find this difficult enough to do because I fall for the tricks. Energy cannot be changed from one form to another, but the total amount of energy does not change. That's the conservation of energy. There's a definition. Is that your definition? That is a definition. A stone of mass 50 grams. 0.05 kilos. The stone is projected with initial velocity of 12 initial energy of 12 joules. All energy is measured in joules. At point X, the potential is 7.2 joules. Calculate the speed. Remember, all the energy remains the same. So there's 12 is the total energy. So the potential energy is 7.2. Therefore, the kinetic energy is 4.8. The kinetic energy and the potential energy add up to the total energy. How many times does this come up in these videos? What does that tell you? It means people who haven't done their work can't rearrange this formula. That means that they're not going to get the 5 marks. Again, can you rearrange, or have you learned that? Put in the bits and pieces. 2, 4.8. Look, see, look. Sitting waiting for you. Calculator out. 2 by 4.8, 9.6. Divided by 0.05. 192. Square root of 192. Square root answer. 8 root 3. What's that in real money? 13.85. Look, they still had a dirty trick sitting waiting for you. Did you read that? The examiner would take a mark off you, and he or she would be laughing, and you'd be going, oh, I didn't see that. 1 mark. We work for every mark. Bye.